Welcome to Probability Session 1. Probability is nothing but a possibility or a chance of an event. Sounds simple, isn't it? But it's not that simple. I have been doing probability for decades and I still find some concepts tricky. So it is common for students to have difficulty in probability, but since the topic is related to real world problems, we can analyze it easily if we know how to relate the things. So we will study all types of questions along with the questions related to real world problems. We have 5 sessions. Session 1 will be having an overview of the topic, all types of problems, important terms, formulas and important concepts. Session 2 will be having some sample questions and session 3 will be having another set of questions. Session 4 will be having questions from previous placement papers and session 5 will be having a practice test for you which is very important, which will give you more clarity about the topic. So don't miss the chance to give this online practice test. And you don't have to worry about the test. If you do not know any question, the answer will be available right there. Probability means possibility. It is a branch of mathematics that deals with the occurrence of a random event. The value is expressed from 0 to 1. Probability has been introduced in maths to predict how likely events are to happen. The meaning of probability is basically the extent to which something is likely to happen. Now let us discuss few important terms used in probability. Experiment, random experiment, sample space, and event. Experiment, an operation which can produce some well-defined results. Random experiment, an operation in which all possible outcomes are known but exact outcome cannot be predicted in advance. Examples: tossing a coin, rolling a dice, drawing a card from a pack of 52 cards. You must be knowing already that all these examples are experiment, but in any of these you cannot predict the exact result before doing the experiment. That is why these are called random experiment. Sample space, set of all possible outcomes in an experiment. While tossing 3 coins, sample space S will be equal to 2 to the power 3, which is equal to 8. See, we have head and tail, 2 options for each coin. That is why we are using number 2, and we have 3 coins. That's why the power of 2 is 3 and our answer is 2 to the power 3. In same way, we will be calculating for dice as well. While throwing 2 dice, S is equal to 6 to the power 2, which is equal to 36. In a dice, we have 6 numbers, so we are using 6 here. And why we have used 6 square? Because we are using 2 dice. So total outcome will be 6 to the power 2, 6 square. So this is the way of finding out sample space of any other experiment. Let us see another example. While tossing 2 coins, S is equal to head head, head tail, tail head and tail tail. Event, any subset of sample space. A sample space can have number of events and any subset of sample space is called an event. Let us discuss some important formula. Probability of occurrence of an event. Probability of E is equal to number of E divided by number of S. Here E is an event and S is a sample space. So probability of an event is equal to number of events divided by number of sample space. This formula will be used in almost all the questions. Now important results on probability. Probability of S, that is sample space, is equal to 1. If we calculate the probability of all possible outcome, that is a sample space, then it is always equal to 1. Probability of an event is always between 0 and 1. For any event A and B, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. And probability of A union B or A intersection B will be discussed later in detail. Probability of A naught is equal to 1 minus probability of A. Examples related to this concept will be discussed later. Types of problems. Number 1, problems based on play cards. So there are total 52 cards and there are 4 different types: spade, club, diamond and heart. And each of these type is having 13 cards in it. Number 2, problems based on dice. Number 3, problems based on coins. And number 4, problems based on different color balls or other items like marbles, etc. Equally likely events. Equally likely events are events that have the same probability or likelihood of occurring. Getting a 1, 2 or 3 on the toss of a die and getting 4, 5 or 6 on the toss of a die are equally likely events since the probabilities of each event are equal. Basically, if 2 or more events have the same probability, then they are called equally likely events. Let us see an example. Example, while throwing a dice, probability of getting a 1 is equal to 1 divided by 6 and probability of getting a 3 is equal to 1 divided by 6. So probability of getting a 1 or 3 will be 1 divided by 6 because sample space will be total outcome, which is 6 here, and event will be 1. So probability will be 1 divided by 6. And both the events have same probability, so they are equally likely events. Example 2. Probability of even numbers is equal to 3 divided by 6, which is equal to 1 divided by 2, and probability of odd numbers is equal to 3 divided by 6, which is equal to 1 divided by 2. See, there are 3 even numbers and 3 odd numbers. So probability will be 3 divided by 6, that is 1 by 2. And both odd and even numbers have same probability, therefore they are equally likely events. Let us consider another example. From the numbers 1, 2, 3, 4, 5, 6, 7, now if we calculate the probability of all even numbers, then how many even numbers are there? 2, 4 and 6. So total 3 and sample space is 7. So probability of even number is equal to 3 divided by 7. Now if we have to calculate the probability of odd numbers, then how many odd numbers are there? 1, 3, 5 and 7. So total 4 odd numbers are there. So probability of odd numbers is equal to 4 divided by 7. Here in this example you can see that both the events have different probability. So they are not equally likely events. Now let us understand a very important concept, the concept of mutually exclusive events. Events which cannot occur at the same time. Mutually exclusive events never have an outcome in common.
If events do not have outcome in common, then definitely their intersection will be 0 because intersection is used to show common results. So probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B, where probability of A intersection B is equal to 0 if A and B are mutually exclusive. For example, while throwing a dice, the event A is equal to getting an odd number and the event B is equal to getting an even number. A and B cannot occur at the same time. So these both events are mutually exclusive. So probability of A union B is equal to 3 divided by 6 plus 3 divided by 6, which is equal to 1. Now let's see another example. Event of getting an odd number and event of getting a number less than 4 can occur at the same time because 1 and 3 both are less than 4 but odd numbers, so these both events are not mutually exclusive.
Now it's very important to understand the concept of independent events. An independent event has no effect on the probability of another event occurring. Or, in other words, independent events are those events whose occurrence is not dependent on any other event. Means event do not depend on any other event. Let us see an example. Example, if we flip a coin in the air and get the outcome as head, then again if we flip the coin but this time we get the outcome as tail. In both cases, occurrence of both events is independent of each other. So if the probability of occurrence of an event A is not affected by the occurrence of another event B, then A and B are said to be independent events. Understanding probability of A union B in independent events. We have already discussed the concept of A union B in mutually exclusive events, where we had to ignore A intersection B because A and B cannot happen together. Now let us see how to apply this formula in another example and how it is different from an independent event. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B, where probability of A intersection B is equal to probability of A into probability of B by A. Here an important thing which you have to understand is P of A intersection B, which is equal to P of A into P of B divided by A. In a simple language, this can be written as P of A intersection B is equal to P of A into P of B happening given that A has happened. If you still have not understood A intersection B here, then look at this example. Example, from the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, event A is equal to even numbers 2, 4, 6, 8, 10 and event B is equal to numbers greater than 5, 6, 7, 8, 9, 10. We have event A, which is a set of all even numbers, and event B, which is a set of numbers which are greater than 5. And numbers greater than 5 are 6, 7, 8, 9 and 10. P A intersection B is equal to 5 divided by 10 into 3 divided by 5 is equal to 3 divided by 10. Here P of A means probability of even numbers and we have 5 even numbers and total 10 numbers are there in sample space. So probability will be 5 by 10. In second part, which is P of B by A, we need to find all even numbers which are there in B. So in 6, 7, 8, 9 and 10, We have 6, 8 and 10. Three numbers. So P of B by A will be 3 divided by 5. And 3 divided by 5 into 5 by 10 is equal to 3 divided by 10. P of A union B is equal to 5 divided by 10 plus 5 divided by 10 minus 3 divided by 10, which is equal to 7 divided by 10. Now let us understand this formula in an independent event. P of A intersection B in independent events. And the formula is P of A intersection B is equal to P of A into P of B. Let us see an example. A is equal to getting a tail while throwing a coin and B is equal to getting 3 while rolling a dice. See here P of A will be 1 by 2 because number of events is 1, which is getting a tail, and P of B will be 1 by 6 because number of event is 1, which is getting a 3 in a dice, and sample space is 6. So P of A intersection B is equal to 1 divided by 2 into 1 divided by 6, which is equal to 1 divided by 12. So P of A union B is equal to 1 divided by 2 plus 1 divided by 6 minus 1 divided by 12, which is equal to 7 divided by 12. Mutually exclusive versus independent events. By now you must have understood the concept of mutually exclusive events and the concept of independent events, but still many students get confused and do not understand the difference between the two concepts. So I am going to give you some example to clear your doubts. Independent events are not mutually exclusive as they can occur together. So mutually exclusive events cannot occur together, but independent events can. Example: A is equal to getting a tail while throwing a coin and B is equal to getting 3 while rolling a dice. Here we have two events A and B, and you can clearly see both the events do not have to do anything with each other. So definitely they are independent. Now you need to find if they can occur together or not. And there is no problem if they occur together, which means they are not mutually exclusive. So A and B are independent events but not mutually exclusive events because they can occur together. Let us see another example. A is equal to Professor X is taking a class and B is equal to student Y is not attending the class. So if a professor is taking a class, then it is possible that some students are not attending the class. So both the events can occur together. So both A and B are independent but not mutually exclusive as they can occur together. Thank you for watching session 1. If you have any doubt, you can write back to me on mathskagurukul.vns@gmail.com. See you in the next session.